Chapter number 12, electricity. Topic number 8, that is heating effects of electric current. Subject science, standard 10. Now, first of all, let us discuss the heating of electric current. Then we will have to talk about the power. We do know that the equation of the power is V cross I, that is voltage into current. And heat is also some sort of energy. So, energy is equal to power into time. We have already studied about this in standard 8, that heat or any energy is always a product of or multiplication of power into time. So, we may write heat is equal to, instead of power, we may write VI. So, heat H is equal to V into I into T, means product of V, I and T. Applying Ohm's law for the V, we may replace V with the IR. So, now we may get the equation of heat or energy, heat energy is equal to I square RT. So, if you are given current passing through any circuit, passing through any resistor for any time T, means value of I, R and T, then you can calculate the amount of heat energy that is going to be liberated through that resistance R. Now, what are the practical applications of electric lighting? No doubt it is undesirable in most cases because it leads to losses, it leads to inefficiency. But at the same time, it is also useful in many applications. For example, in electrical iron, remember the nichrome alloy is used in such heating applications because it is having very high resistivity, geyser and whatnot. Now let us talk about the incandescent lamp. It was invented by Thomas Alva Edison. He was a great scientist, great inventor. He has invented many items, and one of his famous inventions is that of the electrical bulb. Actually, electrical bulb is having a filament which is made up of tungsten, we already talked, and the symbol of tungsten is W from a German word Wolfram, right? So, tungsten is there, electricity passes through this tungsten which is having higher resistivity and also very high melting point so that it doesn't melt away. And part of this heat energy gets converted into light energy. For example, when you're burning wood will burn away, it will give very much heat, and at the same time it gives little light energy also. Same thing was happening in this case also. So electric bulb gives heat and a little amount of light, and we are using that light as our main product. Now next is that of the fuse. It is a protective device containing special wire which melts and breaks the circuit if current exceeds the safe desired level. What is a fuse? It is a protective device containing special wire which melts and breaks the circuit if it exceeds desired safe level. Fuse is something like this looking like, right? It is made up of two parts. One is the base and fuse just laps over the base. So actually fuse does have a wire which is made up of SN. This is also SN and T. So this is the picture in which you can easily see that the wire is broken down due to heavy amount of the current. So whenever there is a heavy amount of current passing through the fuse wire, it will simply melt out. Means fuse wire must have characteristics of high resistance, at the same time very low melting point, say for example approximately 200, so that it melts easily in a very short time whenever a high amount of current pass through a circuit, so that our household applications may not burn away, short circuit may be prevented. Present situation, you might have heard about the short circuiting in many COVID hospitals, and many patients have died due to this short circuiting. So proper ratings of the fuse are mandatory. You should know that there should be fuse of proper rating so that it operates and does not lead to short circuit in the hospital or in our house. So fuse wire are generally made up of tin and lead. Actually SN, that is the Latin word stenon, and stenon, SN stands for stenon, so it's tin, and lead, it is plumbum, Latin word is plumbum. So PB stands for plumbum, SN stands for stenon. So alloy of tin and lead is fuse wire, which is having very high resistance and very low melting point, so that high resistance leads to I square RT. Higher resistance leads to higher heat energy, I square RT. Higher the amount of current, for example 2, then square of 2, that is 4 will be there. But if it is 3, then square of 3 means 9 will be there in the multiplying factor. So higher the amount of current, higher will be the heat, and since it is having low melting point, it will instantly burn away and the circuit will be opened, circuit will be off. Now what is electrical power? We know that rate of doing work is power. Rate of doing work is power. So electrical power is a rate at which electrical energy is dissipated or used or consumed in any electrical circuit. And the standard international unit is watt, that is W, in the memory of James Watt. Power may be represented as V cross I, that is VI. V if we represent by Ohm's law, that is IR, then we may say that power is equal to I square R or V square by R with the help of the Ohm's law. These are various equations which may be utilized in various solution of the equations and solution of the sums. Energy is equal to power into time. You know very well. So E is equal to power into time. While discussing about the heating effects, we are told that heat energy or an energy is equal to V into time into current, or E is equal to V into I into T, or product of voltage, current and time, right? But this unit is very small, so we generally use kilowatt hour. Actually this gives energy in joule. This E is equal to power into time, that is power, we may say VI. So VIT, this is in joule, and joule is a very small amount of energy. So we generally commercially use kWh, that is kilowatt hour, means it is multiplied by 1000 and then it is expressed in an hour. So 3600 seconds will be there. So in 1 kilowatt hour of energy, we may say 1000 watt into 3600 seconds. So 1 kWh or 1 unit of electrical energy will be having 3.63 into 10 raised to 6 joule, means 363 and 000 up to what? Up to 4 extra 0, means 363,000. And we may scientifically write it as 1 kilowatt hour is equal to 3.63 into 10 raised to 6 joules. Thank you.